Hey, what's up, chemistry people? Mr. Boylan here. We're going to do a quick recap of electron configurations and quantum numbers in case you need a little extra practice. To do that, I'm going to make a quick analogy here that will hopefully help you understand why we even do electron configurations, why we use quantum numbers. First, let's go to England. If we take a quick look at the beautiful land of England, we have got, different people in the beautiful country of England. And I want to write a letter to my good friend Harry Potter. Let's think about what I would need to include on an envelope that I would address to good old Harry Potter. Okay, I'm definitely going to need to put his name, like Mr. H. Potter. H stands for Harry. Then I'm going to need to put the cupboard under the stairs. Obviously, I need a larger envelope. Then it's going to be 4 Privet Drive. And that's going to be in the town of Little Winging? The British Winging. But some important things. I've got to make sure that I include the town, the particular house that we're talking about, the particular room in that house, and then the particular person who lives in that particular room. Keep that locked in your noggin. We're going to talk a little bit now about how that applies to electrons in the Electron Cloud. So if we take a quick peek at the Electron Cloud, again analogous to England, there is going to be little towns in my Electron Cloud. And those towns are called first main energy level, second main energy level, third main energy level, and so on. And I want to make sure that I get my letter to the electron that I want to send it to. So I need to include on my envelope here some important information. The main energy level, aka the principal quantum number, N, describe the shape orbital, corresponds to quantum number L. Which particular orbital am I talking about? The orientation, M sub L, and the spin. Which direction is it spinning? M sub S. Now let's compare our two addresses on our two envelopes. The town here, Little Winging, is sort of like the big starting point. I want to make sure it goes to Little Winging and not like Dorchester or Edinburgh or some other crazy town in England. That corresponds to like the main energy level. Like what general town are we in? Are we in Round Rock? Are we in Austin? Are we in Little Winging? Or are we in bloody, I don't know. Or are we in London? London proper. It's like generally where are we at? Next, we've got to nail it down to the house that we're in. 4 Privet Drive. Which is different from 5 Privet Drive. We need to nail down the shape orbital. Are we talking about an S orbital or a P orbital? Then we're going to do the particular room. The cupboard under the stairs, as opposed to the kitchen or the bedroom. That corresponds to the particular orbital that we're talking about. Now, just like some houses only have one room, some orbitals only have one room. Some have 3, some have 5, some have 7. Just depends on the house that you're in. And then lastly, to make sure it gets to the person that we want it to, we've got to address it to that specific person. That corresponds to our spin number in our set of quantum numbers. So just to wrap your head around this, when we write electron configurations, when we use these quantum numbers, we're just describing, in general, where are the electrons. And the set of quantum numbers are what we need to completely describe where we most likely would find that electron in the electron cloud. Okay, so this first example, I'm going to use this periodic table, which is sort of coded to help us better understand what's going on with electron configurations and quantum numbers. So magnesium is right here. And as I think about first drawing the electron configuration in orbital notation for magnesium, you got to remember the Aufbau principle says start in the lowest energy level first, which is the first main energy level. And you're just going to move through those energy levels until you arrive at the element that you're working with, in this case magnesium. So we're going to start in the first main energy level, and we're going to start in the S-type sublevel. Now, the number of electrons that can fit in that 1s sublevel is indicated simply by counting the boxes on the periodic table. Only 2. Now, in orbital notation, I'm going to use arrows to describe my 2 electrons. And notice, in the same orbital, one will be in the up direction, one will be in the down direction. And again, they spin in opposite directions because they're both negatively charged, and that opposite spin sort of allows 2 negative charges, 2 like charges to hang out in the general same space. But after that, we filled up not only that orbital, but also the first main energy level. From there, we have to go to the second main energy level. Now, the second main energy level has 2 sublevels. The first sublevel is the 2s. I can again fit 2 electrons in there. But after the 2s comes the 2p. Now, there are a total of 6 electrons that can fit in the 2b orbitals. And that tells me then, because any orbital can only fit 2 electrons, that there are 3 2p orbitals. Now, you've got to keep Hund's rule in mind. Because the 2p orbitals are all the same energy, we're going to keep those electrons as far away from one another as possible. And then we're going to go back and fill them once we're out of room. Lastly then, after we've filled up the second main energy level, we're going to go to the third main energy level. Now, there are additional sublevels or different additional orbitals that are in the third main energy level, including 3p and 3d. But for magnesium, we only need the 3s. I'm going to put those 2 electrons in there. So your electron configuration for magnesium in orbital notation looks like this. Now, we can condense that in a couple of ways. First, we can write it in standard configuration simply by replacing the arrows with superscripts. So 1s2, 2s2, 2p6, 3s2. We could condense it even further by putting this in noble gas configuration, choosing the noble gas that comes before magnesium. In this case, that noble gas would be neon. You put the symbol for neon in brackets, and then pick up where neon leaves off until you get to magnesium, in this case, 3s2. So we've got orbital configuration, standard configuration, and noble gas configuration. All of which you should be expected to solve or write for on the next exam.